Hi everyone, and welcome back to Dad's Shed. This is part 2 of the video on the manufacture of my little Sine plate. For those of you that have seen part 1, you've seen me do the basic outline. What we're doing in part 2 is going into a little bit more depth on some of the specific elements, cutting the V-grooves, making sure that these ground bars, and the front one is a pivot as well, are in exactly the right place, i.e. at 9-inch centres. So it's how I do that, how I adjust it to make sure they are in the right place. So 2 V-grooves top and 2 V-grooves at the bottom, bit of shaping at the front, and then drilling some holes to get this fitted on so that I can check it out. I'll spend a bit of time explaining some of the setups, because this at 12 inches is really too long for this machine. I think their total travel is about 13. So it's a bit of a struggle, and I've had to change the way I'm planning to do things in order to make up for the fact that the machine won't let me do what I would normally like to do. One of those I'll just explain now is I would normally like to put a face cutter in and face right the way across in one go. Unfortunately, unless I use a very small diameter cutter, which means I could do multiple passes, many passes, I haven't got the clearance at either end to start outside of cut and finish out of cut. It will stop part way through. So I don't like doing that. So I've made a change to the way I was doing my setup so that I'm cutting across rather than lengthways, as I said I originally planned to do. And the one thing that this project has shown me is that I need to be flexible, or I need to think things through a little bit further in advance of actually cutting metal. Because I've made a few decisions on what I was going to do, but when I came to it I suddenly realised that sensibly that wasn't the right way to do it, so I did it a different way. I do hope you find it interesting. This one should take us up to the point where we are almost ready to do some machining, but then I had a further thought and thought, you know, there's a better way of doing this, and that will come up, I would think, in part 3. So I hope you enjoy this. If you watched part 1, thank you for coming back to watch part 2. It's been a bit of a struggle. This has taken me about 3.5 months so far. Anyway, enjoy it. Leave comments please, good or bad. If you tell me I'm doing something wrong, that's really helpful. And like and subscribe please. And I'll speak to you at the end. Enjoy it. Well, welcome back to the shed. Just one small point that some of you may have noticed. I seem to be suffering from an infestation of rubber bath ducks. They seem to be popping up everywhere. Obviously the force field around the shed has not kept the wife out. With the result that I am finding rubber ducks of various sizes just about everywhere. Yeah. Anyway, what are we here doing now? Well, I've done the ends and 2 slots in this piece. I'm now setting it up 90 degrees round. Now this is the master side. It's the side that I put against there and I've machined against. This side is almost totally parallel with it, to within half a thou, but I don't want to try and get it to 0, because if I try and get that side to 0 to match this side, I know I'm going to foul it up. So half a thou I can live with, but that does mean that this is my master reference face. So what I'm doing at the moment is I've put this on here, it's clamped down onto parallels. I've got that bolt at the end there done up, and that clamp is loosely tightened, and I've just been gently using a soft faced mallet, been tapping it across, and with my dial gauge on here I've now got to the point where it is moving the full travel that I've got on here until it actually touches that piece there, with no deviation at all. So I'm quite happy with that. It's going backwards and forwards and it's not moving. The reason it moved is that this is very slightly higher here and it just caught the bottom of the gauge mount. So I'm happy that that is at 90 degrees to the ways. So they will now be, as they were the other way, parallel to the travel of the table. So I can now look to extend those, and then I'll put the V-groove in to take the 1/2 inch round ground bar that I've got that will make the reference points for the sine table. Right, let's move this out of the way, and magically this will all disappear in just a moment or two. What I've got here is a new purchase. It's a Technique bevel cutter. So it's an inserted tip tool. Takes a fairly special triangular insert, which has got a lot of relief on the back edge of it. And it's a chamfer cutter. Now it's a 20mm shank, so I've had to get a cutter holder that will hold 20mm. Now the disadvantage on that is it's huge. I don't know how this is going to work, so let's go in and find out. Okay, right, let's be a little more sensible here. I've taken that through, I've taken just a little bit of a cut along there to get some indication of where we're sitting. Well, what I'm going to do on this is I'm going to take it down until it touches the bottom of the 1/4 inch deep slot that I cut in there. But I don't know how much I've got to do. So let's grab a precision parallel and take it down so that it just touches. Okay, so that is exactly where I need to be. I'd say that's 1/2 inch, but I think I'll double check that. So that's 1/2 inch, the parallel. So I know that's now 1/2 inch off the top surface of that. so if I say Z is now 0.750, enter. So if I now take this up, if I take that down to a quarter, to 5.0, yeah, that looks about right. Now let's see where we go with this. Let's put a little bit of oil on there. Okay, 1781. Maybe 160. Right, well that's cutting on quite nicely, but I don't like the feel of it. So what I think I'll do, I'll take the speed up. And this is a carbide bit after all, so it might be a lot happier at the slightly higher speed. So let's take that up to 970 from 500. And see what we get there. Okay, 160. I'm only going to take a 10th thou cut on this. As I said, I don't know how, never having used a cutter like this before. I'm taking it easy, trying to find my way through it. that looks a bit better. Yeah, that looks a lot better. Okay. This is not going to be a short process. Now, I don't really know what I'm doing with this cutter, so I'm taking it fairly easy. I'm going to take 10th thou cuts. Bit of cutting lubricant, and we'll see how we go. So where are we now? Well, having done the V-groove on this side, I've clocked to that side, and I've done the first few cuts of the V-groove at this end. And that now sits in there quite nicely, so I can now take a measurement. I've got a 6-inch parallel here, although actually what I'm going to do is I'm going to do it properly, and I'm not going to use the 6-inch. I'm going to use 4-inch gauge block, two-inch gauge block. Sorry, what am I talking about? I need 8.5 inches, don't I? So 4, 3 is 7, and 1 is 8.5. Now, because these don't get used very often, they've usually got a small coating on them, which is a sort of anti-rust, and this is an old Matrix Imperial or Coventry Gauge and Tool Company, as it was known at that point, gauge blocks. So I'll just give this a quick squirt down with some solvent, which will clean any of the muck off the ends. Tell you what, I'll clean these up and then I'll come back to you once I've got them in a usable condition. Well, that took a bit longer than I expected because I've had to clean up quite a few of these. Unfortunately, the gauge blocks do not get used very often, and the anti-rust that was obviously put in here many years ago has done a very good job, but it does get a bit sticky, so I've had to clean these up. Now, what I've discovered in doing this, if I can get the last one in, and obviously what I've been doing is going through to find the stack of gauge blocks which will sit in there without pushing this out. And this little stack here does that very well. So it's 8.487. So that's 13 thou off where it should be. So that's that set up. Good use of the gauge blocks for the first time in quite a time. Yeah, don't use them very often, but absolutely marvellous when they are. But what I think I will also do, having got that pile out and got them set up, I think I'll actually go and get a secondary measurement. And I've got, I think, a 12-inch vernier caliper, and I'll put that across the gauge blocks, and that will give me a double check. Right, if I take that, set that roughly at just over 8.5 inches, and try not to knock everything flying. Get these squared up. I get that over there and over here, and I'll just okay, that's square on there, and that is square on there. That will just slide off like that. Well, it reads just under 8.5 on that. 8.4. That actually reads 4.494. 49. That reads at 8.494. So that is slightly different. I think I better do some double, triple checking. Okay, let's have another check. $95. So I make that 8.495. So 5 thou out. Okay, so we'll turn this back on, and what we'll do now is take all these off, put them away, and then move the whole thing this way by 5/1000 of an inch. I'll take then another small cut and then measure again. I need to come this way. Five thou. Now let's do a quick swap to safety glasses. Get that off out of the way. Okay. Alright, let's try a different way this time. And the other option, one other option, of course, okay, that is dead 8.5 inches now. See where we are in here. I've taken another couple of cuts down on the back on the V-slot there. I've got my 2 ground bars which will go sit across here. And what I'm going to do, I think, I might just be a little bit sensible on this one. On this one over here, I'm just going to undo that. Let's move it across the middle. Right, so that's nice and tight down. That's not going anywhere. Unfortunately, I'm not going to get the same over that side because there's not enough room to get anything underneath. But I decided to go for the inside micrometer. And this is one of the many tools I've obtained over the years from eBay. Mainly because they're just not used anymore. So just touching it. Just touching it. Lovely. Well, that's a bit of a relief. Let's just see if I move that along that way a bit and that one along that way a bit. Can I get underneath here? because that won't actually allow me to do it. Well, that's a bit of a shame. I could actually take it all the way up. No. So that's a good check, because now I know that I'm at the right distance across here in the middle, but also at the end. So that means they're parallel, so I don't need to worry too much about that now. So I put that one back up there, take the two bars off, they can sit back in here, wait until I need them. So that's good. So I'm now 60 thou off of where I want to be, so it's going to be another 6 cuts, actually a bit more than that, because the last couple I'll do at 5mm depth of cut. So I'm getting quite a wide V now, so I don't want to push my luck on it. As I say, I'm running actually this quite quickly now at 1660 RPM. I'll come along here a bit. Slacken off the lock. Take that up 10 thou. We're now 50 thou from I thought what I'd do is I'd spend a bit of time explaining my setup on here, because as I said, the problem I have is that this is far too large for this milling machine, so I can't just clamp it down and face mill it or fly cut it, because it just won't do it. The travel is not enough on the table. So I'm going to have to do this in a number of cuts, and I'm going to need to turn it round when I get to there. The tooling holes I put in come in really useful here. So this table is as far out now as it can go. That cutter will miss the nut that's in the middle here, and I've got a parallel sitting here and here. That nut will pull down onto those two parallels, and because this is 20mm thick, it's not going to bend with the amount of pressure I'm putting on it. So I put it on, I've tightened it down with that nut. I've then put 2 clamps that are over the parallel at the back, so this will keep it nice and tight down onto both parallels. What I can then do, once I've done the cut at this end, is put the clamps that are sitting here at the moment out of the way. I'll move the cutter across so that it's just missing these clamps here. I'll put the 2 clamps on at the front, again over the parallels, and then I will undo and remove the bolt or the stud and nut that's in the middle here. So that will mean that it's pulled down tight onto the parallels at all times before I remove any of the other clamping units. So I've decided what I will do is I'll put the unmilled plate in next, so I can do this side at exactly the same setting that I did the other side at, because obviously to then take another 5 thou, 10 thou off, I'm going to need to move the setting. So I thought rather than do that, I'll leave the setting as it is. I'll just clamp this down, mill this side, and then I can do the other side again at the same setting for both plates. And once I've done that, I can play around doing chamfering on the edges, and this one's will stay effectively as is. I'll come back to a few small changes I'm going to make later, but this will stay effectively as is once I've milled it. The other one, I'll need to mill a section out to clear the outer hinge for the front bar. So let's start this one up and get milling on this one. So it's the second cut done over the top of the hole where the hold down bolt would be. So let's use this for a minute. Get some of the swarf that's gone down there out with the magnet. Okay, so that can go back in there. Tighten that down, and then I can take these two off. Move those back out of the way, and that's clamped it back down tight, so that's going to be tight still on the parallel at this end. I say it's not going to be enough torque going on there to bend the plate, not over the short distances involved. So with the plate still in place, I can now move this, release the lock on that axis, move that right over to here. Lock that up again. No, wrong. Can't go that far. So I need to leave enough clearance down that side for the nose of the horizontal spindle to turn. Otherwise I'll clip the thing. You may just notice that at the back here there's a thing that looks a bit like a cork from a sparkling wine bottle, and the reason for that is it is actually a cork from a sparkling wine bottle, and I've just literally put it in there to stop anything going down the spindle, and for 30 International it's quite a nice fit. So I'll do the rest of this off camera because it's basically just rinse and repeat. So I'll come back once I've got this out of the way and the whole lot is surfaced, and then I'll show you where we're going from there. I'll do a quick update here. I've flipped this over to the bottom side, and this is the base plate, and I've been using my recently acquired face mill cutter. It's a 63mm diameter 4 inserted tooth cutter, and it's been doing quite a reasonable job. But it has been giving me a few small issues. The surface finish isn't too bad, but there's a few areas where it seems to be digging in very, very slightly. Not enough to cause a problem, but it's there. So I decided that I would spend a few pound, and it literally is a few pound, on our friend's eBay, and I'm swapping the rather nice gold coloured inserts that came with it for these rather boring grey ones by Seco. So what I've actually done is swapped out the tips for a branded one. Now the main difference is that the unbranded tips that came with this seem to have a wiper surface on it, so a flat, whereas these haven't. And the difference is astonishing. I've actually upped my speed on the spindle to 900 RPM, and that is giving me a phenomenal surface finish. I'm only taking 10 thou out, that's all I really need to, but the surface finish on this is beautiful, and it is much, much better than the one I was getting with the supplied tips. Not that the supplied tips are bad, but it does actually go to show the difference between good quality branded carbide and some of the unbranded stuff that you get supplied with. So that's another good lesson learnt. I should have realised that some time ago, because I've been using some Itomo tips in some of my other bits, and the difference between good quality carbide tips and cheap carbide tips is literally chalk and cheese. So I'm just started doing the other side of this, and I am really pleased with the result. So I just thought I'd break in there. I'm not going to do any more of this because it's boring. All it is traversing backwards and forwards and cutting lots and lots of bits of swarf off. So the swarf is coming off really nicely. The surface finish is excellent. It's going through this like a knife through butter. So I'm just going to put the centre bolt back in and remove these two clamps and do the far side. Then I'll flip it round and do this bit, which I can't reach any other way. But I just thought you might find it interesting to see the difference between a branded carbide tip and an unbranded carbide tip. Yeah, should have done this 2 days ago when I was doing all the cutting, but I didn't receive these tips until this morning. So there you go. But do bear in mind, I would heartily advise, if you're buying carbide tips, spend a little bit more and get branded stuff rather, and there are quite a few people who are selling new old stock branded tips, which can work out no more expensive than run-of-the-mill Chinese produced unbranded items, which may be fine but may not. As you'll recall from a few minutes ago, when I was machining the angled recess to take the ground bars, I checked the inside dimension between the ground bars to make sure it was a dead 8.5 inches, which it wasn't quite. So I've had to adjust that very slightly, only by a few thou, but that now means that this central slot isn't, and I need it to be, because it's got to take the 4mm screws that hold these in place. So what I've just done, and I did video it, but unfortunately part way through the children came running in, is I've clamped this down. I've got one of the ground bars on here being held in place, held down by these two pieces of packing, and I have run my dial gauge across the end, and apart from bits of dust or something that's collected on there, there's no movement. So I'm now happy that the slot is square to the travel of the table. So that's half the job done. The next half is making sure that this is central over the slot, and for that I'll go back to my other piece of equipment, which is the centering gauge, and I'll bring you back once I've got that more or less in place. One of these. Now, I've done this a few times now, so I'm getting used to it. Right, that can go in there and sit in place. All I'm doing now is just tightening down the base. I've put a nut on it just to hold it. And if I go into my electrical drawer here, I can grab a nice small cable tie. And that's on there. Now it's got to go down a bit, or up a bit. Okay, So I've set that up so it should be landing about halfway down the angled face there. I'll take that off. Right, that's going to hit quite hard, so I need to pull that back. Right, that actually zeroes out at 0 on there. It comes round to this side, starts to pull in again, and it's zeroing out at 37. So if I go down to about there, that will now zero out at, oh, that's zeroing out at 42. Yeah, 42. 42. So that's now deflecting exactly the same both sides. So the centre will be over the centre of the slot of the V-way. So that means I'm now happy, and I'll zero that. I'm now happy that my cutter is centred over the V-way, so I can now go down, put the cutter back in and run that slot along, and that will just centralise it and give clearance to drill through. Then after that, I have set both of these up facing each other with the 1/2 inch bars in between, and they sit down perfectly, no rock, nothing. So the next thing is going to be to drill that slot a little bit wider so it gives me clearance on for the holes to come through, and then I've drilled the holes already into the bottom of the V. So all I then need to do is to clamp these together with the bars in between, put them on the table, and then drill through the tapping size holes into the bars, and then drill out clearance size at the top and then tap through. So that's going to take a little bit of time to do. I won't video just doing that. I'll come back once I'm in a position where I might have something of a little more interest to you. And the other thing I need to do is take the bars away, shorten them down to 6 inches for that one, and then look at making the pivot point on these. So that's quite a little bit of work to do. I won't show the machine work. It's basically just cutting the end and chamfering. I'll use the 1/2 inch collet on the 1/2 inch bar, so it should be nice and central, and it's a little bit of drilling, boring and reaming to get the pivot point, which I'll do at 3/8 I think. So that'll do, that should do that. I'll come back to you shortly.